For our project, we wanted to see if we could measure the phenomenon of the home field advantage and determine if it's a superstition or if it's real. For this, we decided to look towards the Magnus Force to see if it could have a significant enough impact on a pro player's game. We got the idea for our experiment from this video here. As you can see, the man is at a dam and he drops a basketball without a rotation off the ledge, and its flight path is slightly unpredictable, but overall does not deviate too far from its original drop zone. Now he puts a small rotation on it, and as you can see, it has a constant acceleration in one direction that skews it far from its original path. It's a pretty significant change in its trajectory. So our observation is that the spin of a football in correlation with wind will greatly change the distance of a football. In this case, that would result in a home field advantage, as a quarterback would be more practiced in his given conditions. So our hypothesis is due to the Magnus Force, the impact of different wind velocities at different football stadiums will impact the performance of the quarterback. We will define the Magnus Force as the cross product between the angular velocity of the football and the velocity of the fluid, in this case air, that the original body is moving in. And then these two are multiplied by the air resistance coefficient, denoted as S. In order to compute the effect of velocity on a Magnus Force, we first need to find the Magnus Force as a function of velocity. We do so by finding our air resistance coefficient and the average rotational velocity of the ball. So we defined air resistance as equal to 1/2 times the density times the area of the body times the coefficient of drag and its velocity squared. We found the density of air to be 1.225 kilograms per meter cubed. The coefficient of drag is 0.25, and the radius of football is 0.0889 meters. So using the Magnus Force and assuming a rotational velocity of 800 RPM, we found the Magnus Force to be equal to 0.014427 in the upward direction. Using basic kinematics and Newtonian physics, we determined that if there's a wind velocity of 15 miles per hour, the total distance of the throw would be 82.36 meters. Without the wind, that total distance changes to 81.54 meters. The difference is 0.8 meters, or about 1 whole meter, and in sports that can be a very significant difference. When everything's on the line and running short on a pass could lose the game and the season, the Magnus Force from a strong wind could be enough to put the pass beyond the wide receiver's arms. In conclusion, the Magnus Force does have a significant effect on the distance traveled. This distance is enough to make an impact on the quarterback's throw, and this difference in distance could be deemed the home field advantage. If a quarterback from a low wind area such as Dallas went to play in Chicago, this factor could be the game deciding difference.